Right, we got a trigonometry question here, and it says calculate the size of angle BAK. So if I drew that triangle on here, it looks something like this. Alright, now I'm actually going to draw it out like this, and it be, sorry, do apologise, that's A, I'll just rub that out. That should be A, that's B over there, and that's K. Now BAK, we've got to find this angle. Right, it says that AKB is 68, so we know that one. We know this side is 21, that's here. And it tells us that BK is 16.5. So we have two angles. All right, we're trying to find that one there. Have two angles, two opposite sides, so it's going to be the sine rule. Okay, so sine rule is sine BAK over its opposite side, 16.5, equals sine of 68 over its opposite side, which equals 21. Rearrange that, and you should end up with BAK equals sine to the minus 1. We're finding an angle, aren't we? Sine to the minus 1 of 16.5 times sine 68 all over 21. Stick that in your calculator, you get 46.8. Okay, so there you go. Now the next question is, and I'm going to rub out what I drew on here, and before I move on to the next bit, I'm going to draw on, it says that we've got to calculate the size of the angle between BK and the plane ABCD. So what we have here is another right. Oh, I was going to do that in a different colour. How annoying. I'm going to do it in a different colour because I promised myself I would. There we go, blue. So I'm going to actually have this here, and I want that angle there. So now if I move on to the next page, we've got, alright, a triangle that looks something like this. Now I'm going to call the point that it meets in the middle, it's not got a letter, but I'm going to call it M because it's going to be in the middle of that. Alright, and B, we're finding this angle theta here. We know that that's 16.5, and we know that the height of the cuboid is 9. So this is very, very simple trigonometry, where we've got cosine, cosine, what am I talking about? We've got sine, because we've got, we'll label opposite and hypotenuse, so it's going to be sine of theta equals 9 over 16.5, so theta is going to be sine to the minus 1 of 9 over 16.5. Again, make sure you're in degrees mode, alright, and stick it in your calculator, you get 33.1. Alright, now with this 3D Pythagoras trigonometry, whatever it is, okay, you will be able to get right angled triangles all over the place. So look for right angled triangles. That they will be in there, otherwise they wouldn't be asking the question.